Hello everyone, in this video we're going to be solving a system of equations. At this point, go ahead and pause the video and try the problem yourself first. This is a very interesting question. We are given two equations and we have three unknowns. No, we're not necessarily looking for integer solutions, so this is not a Diophantine system. But we still have three variables and two equations. So let's go ahead and dive into it. All right, so we have x plus y plus z is equal to 15 and x squared plus y squared plus z squared is equal to 75. So we have the sum of squares and we have the sum. So what can we do with this? So I can just go ahead and take advantage of the identity, which is the x plus y plus z squared. Let's go ahead and expand. That's going to give me x squared plus y squared plus z squared plus 2 times the quantity xy plus xz plus yz. Now, what is so good about this? Well, I do know the sum of xyz, and then if I can get a product like this, maybe I can just find something from there. But what is interesting about this problem is that we're not looking for integer solutions necessarily. They might come up, they might turn out to be integers, but we don't have enough equations, so we have to do something special, right? That's what we're going to do. Okay, let's see. Now, we have the sum as 15, so this is going to be 225. And as you know, the sum of the squares is given as 75. From here, we can actually solve for xy plus xz plus yz. So subtract the 75 from the 225, that's going to be a 150. Divide by 2. And you're going to get xy plus xz plus yz to be 75 as well. Now, what is that supposed to mean? Okay, let's think about this for a minute. So we have the sum of the squares equal to 75, and then xy plus xz plus yz is also equal to 75. What is that supposed to mean? Well, that means they're equal, right? Does that have any meaning? Let's take a look. Okay. X squared plus y squared plus z squared is the same as xy plus xz plus yz. Okay, as is, this may not look very meaningful, but if we do some algebra on it, then it's going to be more meaningful. So let's go ahead and do some algebra. So what we're going to do here is I'm going to take the expression on the right hand side and just subtract it. So it looks like this. I want to get a 0 on the right hand side. That's my goal. Okay, cool. Now, again, this doesn't make much sense as is, but we're going to do a little bit more operation on this. I'm going to multiply everything by 2. And you may be wondering, like, why are we doing that? Because it has a meaning. You'll see in a little bit. Okay. So I'm going to multiply everything by 2. Okay, hopefully you start to realize what's going on here, and that's a very, very special operation here. Okay, now once we do that, this expression becomes more meaningful because now we have the negative 2xy, negative 2xz, negative 2yz. Along with the squares, what does that remind you? Doesn't that remind you that we can complete the squares here? We definitely can. So let's go ahead and do that. So I'm going to borrow x squared from here, put a negative 2xy, and then what I need to complete my square is y squared. So I'm just going to borrow y squared. I still have x squared and y squared left, okay? Then I'll just continue. Since I already used one y squared, let me use the other one. But this time I'm going to pair up y with z, so I do need 2yz. Let me go ahead and write that down. Then I need to continue with z squared. Notice that these are completed squares. These are perfect squares, right? Perfect. Now, what I did was I used the y squared twice. I only used x squared and z squared once, meaning that I can use them again. So now I have x squared left minus 2xz left plus z squared, and the whole thing is equal to 0. Cool. Now, this expression is made up of 3 perfect squares. So let's go ahead and write them. So the first one is x minus y squared. The second one is y minus z squared. And the third one is x minus z squared. And the whole thing is equal to 0. Okay, now what is that supposed to mean? We have an equation in 3 variables, but this is sum of squares. And as you know, square cannot be negative, right? No square can be negative. So how can the sum be 0 then if none of them can be negative? Well, that means they're all 0. So from here we get the awesome result. The conclusion is x minus y is equal to 0, y minus z is equal to 0, and x minus z is equal to 0. Meaning that if you put it all together, this means x equals y equals z. So basically, kind of going backwards, this equation means that x, y, z all have to be equal to each other. Okay? Which is kind of cool. And we could prove that in different ways, of course. Now, once we know that, and we know that the sum of x, y, z is 15, we can just go ahead and plug it in there. We know that x plus y plus z is equal to 15. And they're all equal. This means that x needs to be 5, y needs to be 5, and z needs to be 5. And that's the only solution, only real solution to this system of equations. I hope you enjoyed the video. Thanks for watching. See you in the next one. Until then, take care. Bye-bye. And don't forget to comment, subscribe, and like. See you later.